So here's problem number 13. We've got this 50 square inch thing in the center of a frame. The frame's got 2 inches on the side and 4 inches on top. And we want to find out the overall dimensions that will minimize the amount of paper used. I need to declare a variable or two. And I think I'm going to declare that dimension y. And I think I'm going to declare this dimension x.
Do you just automatically make y longer?
No, I made y go up and down.
Oh, okay.
And now I need a relationship. Since we have two variables, I need a relationship between x and y. Please discuss with your partner in 15 seconds what's the relationship between x and y. One more time? xy equals 50. Great relationship. Okay, now we need a function that we're going to try to maximize or minimize. Area is a function of x and y. And please discuss with your partners really quickly. What is that function?
What are we discussing?
What is this function? We're going to try to minimize the area used. What is that function? What is that function of two variables? How do we translate that diagram and the x and y's into a function of x and y?
You mean y equals self or whatever?
Okay, I'm going to read the question, because the question has always got the embedded in the answer. What are the overall dimensions that will minimize the amount of paper used? So this function is always representative of the thing that I either want to maximize or minimize. I want to minimize it, but it's still an area function, so give me that area function. I think 1/2 of it is going to be x plus 4. Times y plus 8. How many people are like, what the? Where's that coming? Nicole. So where's that coming from? Well, here's this rectangular area that I'm trying to maximize or minimize. So how do I calculate the area of that? Well, I got to measure its width, right? Well, how could I describe that width? Well, it's 2 and then an x and then another 2. It's x plus 4. How about its height? Sorry. I got made fun of last year for saying height.
It's
It's y equals 8 because we've got a 4 plus a y plus another 4. That's a variable, that's a function of two variables. I want a function of a single variable.
So you just take sulfur.
We have two choices.
Y equals 50 over
Y equals 50 over x is one choice.
or x.
X equals 50 over y is the other choice. You get to choose. Y equals? Yeah. You like x's?
Yeah.
I like x's too.
X versus y.
What?
X marks.
X marks the spot. Okay. So every place, so we're going to use this one, and we get x plus 4 times 50 over x plus 8. Clean up and derivative, please. Go. Everybody, everywhere. How did you get it wrong? Well, no, you just declare the entire width to be x,
Yeah.
right? By the
Then
insert.
what is
I'm not whipping hard.
You declare your variables differently, but you're perfectly consistent with your definition. It's not a coincidence that you get the right answer. You did everything right. I made different choices, and we can see from our choices whether my way ends up being less algebraically clumsy. But we're still going to end up at the same place and everything's done. compare your work to my work. Okay, so Olivia, when you look at your stuff, do you find that your derivative is a lot harder to deal with than my derivative? Okay. Okay, so what was the step? We do a cleanup step, we do a derivative step, then what? Set it equal to 0, and then try to see where we have intervals of increasing and decreasing, because they'll tell us where minimums and maximums occur. Oh, let's see. If I take that, I set it equal to 0. Uh, 200 over x squared is equal to 8. How about that means that 200 divided by 8 is equal... So x squared is equal to 5? No. 8 goes into 200 more than 5 times. 25? I like that better. So I got x is equal to plus or minus 5. Okay, hold on. X is equal to plus or minus 5. But we're dealing with lengths, and we don't think of lengths as being negative. Here's my A prime number line. There's my 5. What do we have? When x is 0, I get undefined. So don't go there. But when x is really, really big, I'm positive. Because this thing right here is pretty small. And then on the other side of that, I'm negative. So if A prime goes from positive to negative, from negative to positive, that means A is going from decreasing to increasing. That means the thing that's going on at 5 must be a minimum.
The book mentioned taking the second derivative, but in place of doing that, this is quicker, right?
Yeah, I mean, you can take the second derivative of this, and it'll also tell you whether at this location you are increasing, you have a local maximum or minimum using the second derivative test. All right. If x is equal to 5, then y is equal to 10. And the question, which is on the overall dimensions, is going to be, the width is going to be 9, and the height is going to be 18. Why does it, when a 1-year-old is learning to walk, why does it look so clumsy? Because it needs practice. And the more you practice, the more easily this is going to flow. Easily?
It sounds weird.
Yeah. Everything out of my mouth sounds weird. Yeah.
Is it coincidental that the border on the outside, that like these are half of what that is, and the final dimensions, that's half of what that is?
I don't know if that's coincidental or not. It's worth an exploration. Feel free.
It's not English, that's hard to
Yeah, just stay there.
But I speak English sometimes.
Sometimes.
All right. That's number 13.